So now we will introduce the last speaker of the session. He is online, Daniel Vildozo. Daniel Vildozo is a PhD in environmental chemistry from the University Claude Bernard Lyon in France. And then, he did a research scientist work at the IRC Lyon and in other places, but since 2016, he works at Condorchem, and right now he's the general manager in this company. Okay, he will talk about zero liquid discharge approaches in industrial wastewater treatment. Thank you very much, and the floor is yours.
Thanks to CN2 for the invitation to this conference. I'm very sad that I cannot be present in Barcelona because I know that you have a very sunny day today, and here in Lyon is very ugly day with a lot of rain and very cold. So we are going to begin the session 3. This is the session that is going to continue tomorrow. And our focus is to talk about the industrial vision of companies like Condorchem to make some introductions. So what we are working on in industrial cases and what's going on in environmental products that we made. I'm going to talk about the zero liquid discharge in industrial water waste treatment. And what I want to share with you is just an introduction of ZLD. I'm just going to present what is Condorchem Envitech. Condorchem Envitech is an environmental company that we work in water treatment, air treatment, and we treat also recycle, we valorize the compounds that we found in the water wastewater uses and recover energy in their treatment problems that we can find with our clients. We have 27 years of experience. We have more than 400 products. It's a worldwide company, and we have made products in more than 34 different countries. And we have different offices. We have our main office is in Barcelona. We have an office here in Lyon and in Mexico, and in San Francisco, and in Worcester and England for our different products that we have worldwide. This is the different products that we have worldwide. So we, as you can see, we made products in different countries, in different continents. I want to show you this because we receive, in order that I can show you that we receive the problems and demands of many kind of companies, of different kind of industrials and of different kind of problematics and different kind of regulations, because each country has a different kind of regulation. So we have, we can give you, let's say, a very large and open opinion about what's going on in environmental problems, because we can see each year which is the demand of each country, of each kind of industrial. Our demands are worldwide, and so we have a good idea what's going on in the problematic of environmental problems that industrials can have. Just to give you a small introduction about the reuse and valorization of wastewater treatment. Before the problematic and the wastewater treatment was the purity was the source reduction, that as we can see in this picture. That means that the first problematic to resolve was source reduction of the pollutants that we can find in water in the wastewater of the industrial, and the outlet elimination. So the demand at the beginning was we have to reduce the pollution in the water in the process. If we cannot do it, we are going to make a system to eliminate the wastewater. And then, as we can see, the last of the priority was the reuse of the water. So at the beginning of the Condorchem 10 years ago, all our priorities that we made was focused just on the treatment at the end, and that's all. Let's treat, let's go down with the pollution at the levels that are legal levels of the regulation authorities, and that's all. And we forget the problem. That was the product that we made at the beginning. But since 10 years ago, and since this was changing, and this was increasing with a different point of view of how to attack this problem. And the new priorities are changed. So what we are focused since 5 years ago in the products that we made worldwide is not only the priority of the water treatment at the end of the process that the industrials they have. We don't have to treat the pollution in the water. We have to reuse the water that we are going to treat. So that was changing, and this is changing so more going very fast. So this kind of different mentality of the demand that we have from our clients. Just for example, in last year, in 2020, 7% of the products that we made in the water products that we made of Condorchem, 70% was from reuse. That means that we were not only focused on the demand of the client of the treatment of the water, was also in how we can reuse this water, because now there are many industrial companies that they were told that in the next years they have to make a reduction of the water that they use. For example, right now we are talking about one company here in France, and they told them that in the next 3 years they have to reduce 30% of the fresh water that they use. So this is not only this is an example of which is the problematic of that different companies can have now in the problematic of the wastewater treatment. That's the reason that the importance of what we made as a solution as a company. We work in the ZLD, that means zero liquid discharge. ZLD applies this technology that it applies when we have to treat water, and the more percentage of the water that is contaminated is water inside. So there's the first condition, and this water is contaminated by different things like salts, chlorides, nitrates, sulfates, phosphates, or metals, different kind of metals, or different organic substance of all kinds. So when we have water contaminated with this kind of compounds, we can apply what we call ZLD technology. When we can use ZLD, ZLD technology we can use, let's say that for me in almost every kind of industry. Just in this presentation, I mentioned like a list, for example, industrials that they have emulsions, colorants, water from processed water, from different kind of industrial, from chemical, pharmaceutical, cosmetic, working bath, galvanic process, graphic art, printing companies. And we have also, we can use it in leachates from municipal solid waste. A lot we can use it in biogas process in order to treat the digestate and beverage and food industry that they use a lot of quantities of water, energy generation, paper industry. And some application that we didn't put in this list, but this is increasing a lot, is treatment of the effluents that came from the electric car recyclation of the batteries of the electrical car. This is some problems that we can resolve with zero liquid discharge, and this kind of effluents. We are going to have a mix of water, acid, and metals, and we can use this technology in order to treat and recover from one side the acids and from other side the metals. And we already sell 2 pilots with in order to treat this. This is a growing very fast demand that we are going to have in the next years. Once that all the batteries in the cars that we are using now are going to arrive, and we have to recycle it. I'm going to explain some steps that we need in order to make the ZLD process. First of all, we have to make a pre-treatment of the effluent. It depends on what kind of effluent we have. Before going to the ZLD technology, we have to pre-treat this effluent, and we can made it with different technologies. Biological process, classical biological process. If we have a lot of organic waste inside, if we have a lot of particulate matter, we can make some chemical process for like flocculation or precipitation, or we can use just different kind of filtrations in order to prepare and in order to separate the particular matter that is in this effluent before we are going to send it to the ZLD. This part is really important, because if we can make a good pre-treatment, we can avoid several costs that we can have in the ZLD treatment. This is an schematic let's say conceptual of the ZLD. We can see that we can have the wastewater. This wastewater it can be used here with different kind of technologies. We have a membrane ultrafiltration, we have electrodialysis, we have reverse osmosis, and these kind of technologies, we make a first step of the ZLD technology. We are going to make in this phase, we are going to separate, and we are going to obtain clean water, and then we are going to concentrate the wastewater. This concentrate wastewater, we are going to send that to a second step, that is the evaporator and desalination systems. And after this second step, we are going to obtain water treated that we can reuse in the factory or on the industrial company, and we are going to obtain some solids. We are going to recover some materials that, if we can valorize, we can make a valorization to reuse in the factory, or we are going to sell that like like something that we can sell to use it in other factories, or is going to be treated, or is going to go to, if we cannot make valorization solid, we are going to send it to wastewater disposal. So this is a conceptual explanation of what is zero liquid discharge. Let's say that is all the steps that we can have it. But the most classic, really classic installations that we made as Condorchem and that we can find of zero liquid discharge, we have these three technologies that we can use. We can see that we have here the first step is going to be a reverse osmosis. We are going to treat here a lot of quantity of water, and then we are going to treat clean water, and we are going to have concentrate wastewater here. This concentrate wastewater here, we are going to send it to an evaporation system. In this system, we are going to have a second step of concentrate. So we are going to reconcentrate the wastewater. In this phase, we are going to in the first membrane technology, we are going to just concentrate. In this second step that we are going to use an evaporator unit, we are going to obtain a liquor of the pollutants. The pollutants are going to we are going to obtain also clean water from one side, and from the other side we're going to obtain a liquor that is going to be really concentrated. Sometimes we can stop here the process, and sometimes if we know that we can make a third step in order to valorize the pollutants that we are going to obtain, we can go to a third phase that is going to be a crystallization. In this crystallization system, we are going to obtain water treatment also, but we are going to obtain solids. These solids that we are going to obtain from this unit, we can reuse it, or it's going to go to external disposal unit. In the ZLD technology, let's say that the unit, one of the units, not the most important, but let's say the heart of the process is the evaporation unit, and this is what Condorchem built as a unit. So these kind of units we can obtain with different models, and this is why ZLD is not an easy process to apply, because we can have, as you can see here in the picture, different kind of models of units, industrial units that we can install, depending on what kind of effluents we have, depending on the parameters of the effluents that we have, depending on the pollutants that we have. And these units, we can make it with electrical energy, we can make it with thermal energy, we can obtain, we can make just to make an evaporation and obtain clean water, or we can make it in order to obtain crystals, solid. So this is why the ZLD is very difficult to install, because there is a lot of engineering, there is a lot of laboratory tests, and that's what we're going to show after. There's a lot of pilot tests that we have to make in order to choose the best technologies that we can apply, because what we want to see is we work a lot with cost, with investment costs, in order to show our clients that the ZLD can be applied to his process, and show them what is the cost that they're going to have if they apply this technology. That was for the part of the evaporation systems, and this is also for the crystallization units. That, as you can see, there we have a lot of technologies. So we have some models that we can have. We can obtain a slurry effluents, and some models that we can obtain crystal solid salts. Depending on what is going to be the target of the product. But let's talk what for me, for you, that is as an institute, is your of research, your interest, is that in what we can go when we can find the innovation of this kind of in the CLD process that we can apply. So the emerging new technologies that we are searching as a company right now in order to improve the zero liquid discharge is the first stage that I explained before. That means that we know that the evaporation and the crystallization systems are very physical technology, but we have to minimize the size of this equipment. So our first stage has to be more performant as the technologies that we have until now. And there is some development, and there is a lot of people that are working in order to improve this membrane technology that is going to come at the beginning of the CLD process. There are some advance in membrane distillation, as we can see here, and there's some advance of new materials from forward osmosis. And the last technology that there is a lot of studies is the electrodialysis and reverse electrodialysis technology. So this is now let's say the emerging new technologies in order to improve and be more effective in this first stage in order to have a better performance of the zero liquid discharge. We can talk about some advantage and disadvantage. Let's talk first the disadvantage of the zero liquid of the CLD. It's a high energy consumption. This is a problem. High capital cost of investment of when we have to buy of the units, because we have to treat a very high quantity of volume of water. In some cases, we have to install a pilot scale tests in order to validate the full scale performance, because we are treating here a problem with a mix of many technologies that are going to be installed one after the other. And sometimes when we don't have the experience with this new effluent, with a new matrix and new pollutants to treat, we have to start a pilot scale in order to determine the efficacy, in order to determine also the investment costs that we can have. It's a project in project time. To apply this kind of solutions is for a project is 60% of the time is going to be research, laboratory tests, and pilot tests, and only 30% of the installation and fabrication of the units. Because that is the reason that we like to imply a CLD project, because there's a lot of research in this. That means that we have the units, we have the technology, but we have to be sure of how it's going to work. So there's a lot of research in laboratory. Our clients send us many kind of water that we receive in our laboratory. So we make, as you, a lot of lab experience in our labs. We make a full analysis of the effluent. We make a lot of laboratory modelizations in order to see how it's going to work with a membrane technology, how it's going to work with evaporation, if we are going to have problems with this kind of effluent. But our research, the difference that we made in our laboratory is that we use the parameters of our industrial unit systems. So it's related for a parameter. The efficacy that we made in laboratory is related with a parameter that we put see in our industrial units. So we can have an idea of how it's going to work this our units if we make if we use this effluent that the client sent us. So there's a lot of research and laboratory tests in order when we finally decide what kind of equipments we are going to put, if we are going to put reverse osmosis, ultrafiltration system, or electrodialysis, or what kind of model of evaporation system we are going to use. So there's a lot of engineering study before we go to the final installation of the unit. And the other disadvantage is that in the first stage, the membrane technology is right now is energy efficient and cost-effective membrane is in development. So what we need right now is we need new nanomaterials that we can put in these membranes, and we can use it in order to be very selective with the problematic of that we can have in the pollutants of the different kind of industrials. So this is what we are searching now in order to how we can improve this membrane technologies with new nanomaterials that we can put inside in order to achieve a better performance. So we can go down with the, we are going to go down with the cost and the energy use that we need in order to apply more and more the ZLD technology. So that's in this point that you can help us in order to develop this kind of new materials. Let's finish with the advantage of the ZLD. It's an effective solution. That means that we, in many cases, we really can obtain clean water and that they can be reused in the process. So that is something that we can really achieve, treating different kind of wastewater from different kind of companies. We can treat very large volumes of water. So we are not, thanks to the membrane stage system, we can treat very high volumes of water, and in order to reuse and to obtain large volumes of water to be reused in the main factory. We can reduce the cost of management wastewater for disposal. Sometimes our clients have to send to external disposal and pay a lot of cost for this disposal, and we can avoid this with this kind of technology. We can also recover products. That's what we are doing a lot in other projects with our clients. We search how we can recover the pollutants and how we can reuse it, or how we can valorize this. And of course, the most important thing, we obtain, we can recycle the water on site in the same factory, and we can obtain the water in order to reuse it in different process of the same company. Thank you for your time. I know that this is the last conference from me today. So I hope that if you visit Lyon, just passed and said hi to Condorchem Envitech Leon. It's a really nice city. We don't have the sunny days as you have in Barcelona, but you can have a very nice city where you can drink good wine and have nice French food. Thank you.
Okay, thank you very much for the nice vision, yeah, of your talk. Yes, as we give an applause. Yeah, it's a pity that you could not come presentially, yeah, but in order to interact more, yeah. But
yes,
I'm sure that there will be other opportunities for that. And now the talk is under discussion. I don't know if some of you wants to ask something. Just checking. So if not, yeah, I would like to ask you. So you are already trying, or have you already using some nanomaterials for the membrane, or to test any, or like a carbon based materials or metal organic frameworks, or?
We are interested in metal and MOF, and metal organic frameworks. Right now, we are interested in how we can recover metals. If we can, we know that there is a MOF development in order to treat metals that are in wastewater. And the good thing for us is to develop. This is one. It can be one of the needs that we have in industry. That means that to use some nanomaterials that we can put in the membranes, and then we can reuse these membranes in order to be very selective. To treat very different kind of effluents from different industrial. So this for us is very important because we can go very down in, if we're very selective in this first stage, we can go down in the cost of the investment of these kind of solutions. So this is for me a line that it can be worked. And there's some a need that we have as an environmental company.
In the group, in the ICN, in the Institute of Nanoscience and Nanotechnology, we have a group that is specialized in metal organic frameworks. Yeah, that I think that could be a very interesting point of meeting. I don't know if you already have started any collaboration with them.
Yeah, I'm talking with, I know Daniel Marposch.
Yeah.
Yeah, so we try to make something together in order to develop the MOF and use or what we can help CN2 is to give our point of view of industrials. Tell you the need that we have right now. The need that we have right now is the market, so is the need of the industrials. So we can go ahead with the development of this. That's the reason that I present today the ZLD technology, because the water treatment, the future of the water treatment is the reuse of the water. That's the reuse and the valorization of the pollutants. So in order to we can make it more successful if we can go down with the cost, and we have to be very selective. So I know that with nanomaterials we can be very selective. So and this is something that we didn't find right now. Commercially speaking, we cannot find a membrane with very selective target. So this is something that maybe we can develop together.
Okay, we wait for you here.
Okay, next time.
For the next time, yeah. So, okay. Thank you very much for your talk, and I would like to thank all the speakers of today, and with a big applause for them.
Thank you very much. Bye-bye.